All right, everybody, the fifth video here in this series goes through, well, what's a little bit more geometry based than anything, but something we'll cover tremendously in Unit 3 from this CED involving trig, but are your sine, cosine, and tangent functions. This will be section 3 from the review packet that can be found on the Google Classroom page. I'm going to try to find my way into seeing how I can get Desmos to work here. I don't know if I can, but we'll try. Let's have some fun. All right, first things first here, they're given a triangle of a side 3, a side 4, and a missing side over here. These are the two legs of a triangle. This would be technically what I would call side A, side B, and this would be side C. Using the Pythagorean theorem to c squared equals a squared plus b squared. I think we'll all agree it's c squared equals a squared plus b squared, not a squared plus b squared equals c squared. Civilized mathematicians put the c value first. Anyway, plugging all the values into the Pythagorean theorem gets us a 5 as our hypotenuse value. It is a 3, 4, 5 Pythagorean triple. I want to use basic numbers here. Now, there are 6 major trig functions. Only 3 of them really matter. The first is sine, the second would be cosine, and the third would be tangent of theta. Sine is a relationship of opposite over hypotenuse. Cosine has a relationship of adjacent over hypotenuse, and tangent is your opposite over adjacent. Now, how do you know which angle is opposite adjacent hypotenuse? It's this crazy looking little symbol right here. This symbol is the Greek letter theta. This theta tells us the angle from where we're looking to have perspective. What you almost have to do is picture yourself, a lot more here. Picture yourself standing in that theta. Now, from where you are, you have 3 sides of a triangle, opposite, adjacent, hypotenuse. One of them doesn't ever change its location, and that's hypotenuse because it's always the side opposite the 90-degree angle in any right triangle. So, by process of elimination, I know that this here is my hypotenuse. Now I have a 50-50 shot of calling this 3 my opposite or this 4 my opposite. The fact of where I'm standing right here, it's not right. Here's a smiley face. The fact that I'm standing right here and this 3 is across from me makes this 3 my across or my opposite side. So this 3 is my opposite. Adjacent must be this value 4. Now, I'll be honest. Hypotenuse is usually the most direct side of any right triangle to identify. Opposite's the next. The word adjacent is one of the most difficult words in all of math, in my humble opinion, to define. That's why I leave it for the end. So, my opposite side here is a 3, my adjacent's a 4, my hypotenuse is a 5. Trig functions are nothing more than just ratios between 2 sides of any given triangle. So, if I take my opposite over my hypotenuse here, I end up getting 3 over 5, and there's our very first problem. Using the same values we have here in this triangle and this setup, I'm going to do my best to answer numbers 2, 3, 4, and 5. All right, so the next problem asks us for the cosine of this theta. Again, picture yourself with a little different hair and probably more of a smile. Anyway, picture yourself standing in this corner wherever theta might be. My opposite, my adjacent, my hypotenuse. Cosine's defined as adjacent over hypotenuse. So in this case, it's 4 over 5. Most of your trig problems set up like this are very basic, and yes, they are that straightforward. It's just more of a review from hopefully what you saw or remember from your geometry days. Next up, tangent, defined as opposite over adjacent. So in this case, I have my opposite as a 3, and I have my adjacent side as a 4. Not all that bad. All right, how much worse can they get? All right, so here we go. All of a sudden, they want to know what theta actually equals. Most of this course is going to be in radians. We'll talk about radians down the road. But for right now, I want you to know that angle measures are part of trig functions. If you know that your sine of theta is equal to opposite over hypotenuse, well, we take this simple ratio. I could also pick cosine. I can also pick tangent. But you take this simple ratio and we fill in what we know. I don't have an angle measure here. And yes, I know this is 90 here. But what do I know? Well, most of math is just like a puzzle. You got to fill in what you know and hopefully figure out the rest. My opposite side here is a 3. My hypotenuse is a 5. So let's fill that in. Now, I have this, well, not yet. That's better. I have this theta that sits here. Somehow I have to get theta by itself, which means I have to get rid of this sign. Trig functions, like all functions, have 3 parts. You have the function itself, the argument of that function, and then whatever it may be equal to. This is not the sine times theta. It's the sine of theta, meaning you're taking the sine of some value. I wouldn't say anything different, but if I had this radical or square root of x equals 4, think about what we're saying here. This is the square root of x. It's some function that is a radical, that is this square root, that we're taking of x. The same thing here with that keyword of is occurring here for this sine. The sine of theta. Well, how would you get rid of this square root? You'd perform an operation on both the left and the right side. This 2 cancels because there's a little index 2 here, and that's how the math kind of shakes out. You get x equal to 16. By squaring both sides or going backward and saying x squared equals 25, taking the square root of both sides to get x equals plus or minus 5. Yes, there's a plus or minus there when you take the square root of both sides. What's actually occurring here are inverse operations. The square root and a squared are inverse functions of each other, just like the square root and this squared are inverse of each other. The reason why they cancel is because they are inverses of each other. So there's got to be an inverse of sine, and there is. Technically, it's a sine with a little negative 1 that sits there. The sine and the sine cancel here, leaving you with theta equals the inverse sine of 3/5. Now, all of a sudden on your calculators, if you're using a Casio or if you're using the NCalc FX app on your phone, if you hit shift or second, you'll see the sign with a little negative 1. Punching in that sign with a little negative 1 of 3/5 gets you theta equals 36.87 degrees. So I could have easily picked tangent of theta equals opposite over adjacent, or cosine of theta equals adjacent over hypotenuse. I would use the inverse tangent or inverse cosine functions of those ratios in order to get the same exact degree measure. Anytime we're looking for an angle in this class, we'll always use an inverse function of trig to get there. The last question doesn't even involve trig. It just says, what's the missing angle? Well, what's this angle measure here? Well, if you know 180 is in a triangle, minus the 90 that we have, minus the 36.87 degrees that we have, you end up getting 53.13 degrees. So this missing angle here, 53.13 degrees. Trig will be an enormous portion of this course. It's going to be all of Unit 3. When we get there, the basic knowledge and basic understanding of what trig functions are and how they operate will be required. Before we say goodbye in this video, don't forget to go check out the DeltaMath assignment. When you go to DeltaMath.com, click Sign In with Google. You'll see the AP Pre-Calculus Summer section ready to go. Thanks, guys.